Okay, don't let this thing scare you, right? What is the wavelength of, that's just a frequency. Now notice it's 89.1 megahertz, right? So it's 89.1 times 10 to the 6. That's what mega means. So don't let that scare you, right? And then the other thing is that it's a radio wave, and you need to know that a radio wave, microwave, infrared light, ultraviolet X-ray, fight, 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 gamma ray, yeah, physics, all of those things are electromagnetic waves. They all travel through a vacuum, at least, the speed of light. Okay, they slow down in other materials, but there it is, right? So we're going to use V equals F lambda, right? And then what are we trying to find? We're trying to find the wavelength, right? Okay, so make the little triangle, right? V, F, lambda, do. Okay, wavelength would be velocity over frequency, right? So wavelength is velocity over frequency. It's 3.00 times 10 to the 8th meters per second divided by the frequency, which is this guy. Hertz. Okay. So 3E8 divided by, so in my calculator I'm going 3E8 using a scientific notation, right? Divided by 89.1 E6. It's that easy, right? 89.1 E6, and I get 3.367, and then a bunch of change, like 0, 0, and all this stuff, right? Like that. So yeah, there it is, right? So this is the wavelength. This is actually KMHD. Okay, and then the cool thing about this, you can, by the way, stop listening to this. I'm just going to go on and on about, you know. But the cool thing about this is if you make an antenna, FM antennas look like this. Right? There's a little part here that connects to your stereo, like that. There's a little thing that's like this. If you make this thing 3.37 meters long, right? That whatever that wavelength is, it actually is tuned to the radio station. If the radio station is here symmetrically, you know, so it hits this thing like that, it'll pick up that station really well. It's kind of cool, huh?